afternoon, all of you. My name is Sonali Tambe. Today's date is 18 July 2024. My technical topic name is Architecture of JVM in Java. The JVM stands for Java Virtual Machine. It acts as a runtime engine to run Java applications. JVM is the one actually calls the main method present in a Java code. JVM is a part of JRE. JRE stands for Java Runtime Environment. Java applications are called WORA, means write once, run anywhere. This means a program can develop Java code on one system and can accept it to run on any other Java enabled system without any adjustment. This is all possible because of JVM. When we compile a Java file, a java.file, files contains a bytecode with the same class names present in Java file are generated by the Java compiler. These class files goes into various steps when we run it. These steps together describe the whole JVM. Class loader subsystems means it is mainly responsible for three activities. There is that activities is firstly loading, then linking, first loading, second linking, and third initialization. The loading means the class loader reads the dot class file and generate the corresponding binary data and save it in the method area. For each dot class file in JVM stores the following information in the this means I tell some information about the method area, the fully qualified name of the loaded class and its immediate parents class, whether the dot class file is related to a class or interface or in new modifier, variables and methods and some information etc. After loading the dot class file, JVM creates an objects type classes to represent this file in the heap memory. Uh, that notes that this object is of type class predefined in Java language package. This class object can be used to the programmer for getting class level information like the name of the class, parent name, method and variables information etc. To get this object reference, we can use get class function method of object class. That is the then I tell you some JVM memory, some information. Method area. First of all, method area. In the method area, all class level information like class name, immediate parent class name, method and variables information etc. are stored in including static variables. There is only one method area per JVM and it is a shared resource. Second is heap area. Information of all objects is stored in the heap area. There is also one heap and also a JVM. It is also a shared resource. Then third is stack area. Uh, for every uh, for every thread, JVM creates one runtime stack which is stored here. Every block of this stack is called activation record. Stack frame which stores methods and calls. All local variables of that method are stored in their corresponding frame. After a thread terminate, its runtime stack will be destroyed by JVM. It is not a shared resources. PC registers. For this PC register, store addresses of current execution instructions of a thread. Obviously, each thread has a separate PC and register a native method stacks. Uh, for every thread, a separate native stack is created to it store native method information. Fifth is execution engine. The execution engine execute the dot class byte code. It is read and byte code line by line. Uses the data and information present in various memory area and executes instructions. It can be classified into three parts. Their part name is first of all interpreter. It interprets the bytecode line by line and then executes. The disadvantages here is that when one method is called multiple times, every time interpretation is required. Second is just in time, that is means JIT. The JIT compiler, it is used to increase the efficiency of an interpreter. It compiles the entire bytecode and changes it to native code to whenever the interpreter sees repeated method calls. JIT provides direct native code for that part, so reinterpretation is not required. Then thus efficiency is improved. Garbage collector, it destroy unreference object for more on garbage collector. Refer garbage collector, Java native interface means JNI. That is, it is an interface that interacts with the native method libraries and provides the native libraries, that is C, C++, and required for the execution. It enables JVM to call C or C++. Then plus libraries and to be called by C and C++ libraries which may be specific to a hardware. Native method libraries, that is means it is a collection of the native libraries C and C++, which are required by execution engine, and JVM follows the delegation hierarchy principles to load classes and system class loader. Then delegate load request to extension and class loader, and extension class loader delegates request and bootstrap class, and it's also if class found in the bootstrap path the class is loaded, otherwise request again transfers to the extension class loader, and then to the system class loader. At last, if the system class loader fails to load class, then we get runtime verification in JVM. After the class loader, the JVM loads the bytecode of .class file to the machine. The bytecode in first check for validity by the verifier, and this process and called as that is called as verification. The verifier and performs as much checking as possible at the linking, so that expensive operation performed by the interpreter as at the runtime can be eliminated. That is, enhance the performance of the interpreter. Java virtual machine, that is for stack area. For every thread, JVM creates a separate stack at the time of thread creation. The memory of Java means virtual machine stack does not need to a contiguous contiguous. The Java virtual machines only perform two operations directly. Stack Java stacks, it pushes and pops frames, and stack for a particular thread may be terminated as run time stack. Then every method call performed by the thread is stored in the corresponding runtime stack, including parameters, local variables, intermediates, and all. The Java is the stands meanwhile the Java virtual machines. Thank you.